Hi, everybody. Thanks for joining me. So, in your last lesson, what would happen is I would describe the transformations that happen to a graph, and it was your job to write the new equation for that newly transformed function. Well, today we're going to switch it, okay? And instead I'm going to give you the equation, and you need to graph it. You need to show me what it looks like. So by looking at an equation, how do we determine the transformations that happen to a graph, and how do we actually go about graphing these new points? All right, so one thing that, first thing I want you to remember is that stretching and reflecting comes through multiplication. When we multiply y values by a number, like let's say I multiply y values by 3, that's going to take them and stretch them up. If I multiply by y's by 1/2, that's going to vertically compress, vertically squish them. Okay? Same with horizontal. Stretching and reflecting comes from multiplication. When we stretch and reflecting, we're multiplying the x or the y values. Translating means to move or to shift. Translations come from adding. Right? If I add a certain number to the y values, that's going to move all the y values up. If I subtract from a y value, it's going to move all the y values down, all those points. Okay? Now, of course, we could add to move one way, but subtract to move the other. Okay? Same with stretching, right? If we multiply y's by 2, it's going to stretch them. If we multiply y's by 1/2, it's going to compress them. All right, but I'm just going to say multiplying and adding. And if you think about order of operations in mathematics, right? What do we always do? Don't we multiply before we add, right? We multiply or divide before we add or subtract. Okay? That's why, okay, when I say this next line from what we have up here, is that we always stretch and reflect on our graphs before we move our graphs. Okay? We do our vertical stretches or horizontal stretches or compressions. We do our reflections first because they come from multiplication. Once we've stretched or reflect, then we move the graph. Then we translate it, okay? Because that comes through addition and subtraction. Remember that vertical transformations are always done to y values. And horizontal transformations are always done to x values. Okay. So let's walk through an example. Now here I gave you a graph. I made it up. I'm not telling you what the actual equations are, but let's just call this graph f of x. Okay, kind of a goofy little graph. What I'm asking us to do now is graph g of x so that it's 2 times f of x. Now in our last lesson we talked a lot about inside versus outside. Is it something we're doing to x's or is it something that we're doing to y's? Remember that f of x, this, is really y. So what are we doing here? We're taking 2 times the y values. So what I want you to do in these type of problems is to list the transformations that you do in order and then graph each step. So my first and only transformation that I'm going to do, if I multiply the y's by 2, that's vertically stretching the graph by 2. And how do I get my new points? I multiply the y values by 2. So this is points, the 0 is 0, 1, right? Well, if I take the y value 1 and multiply it by 2, the point 0, 1 now becomes the point 0, 2. This is the point 1, 2. Well, double the y value, multiply it by 2. Now it's 1, 4. 2, 3 becomes 2, 6. 3, 2 becomes 3, 4. Okay, let's see here. That's what? 2.5. 2.5 times 2 is 5. And 3 times 2 is 6. So my new graph for g of x looks like that. It's f of x vertically stretched by 2. Next example. Okay, there's a lot more going on here. Okay. Now, the first thing I notice is the negative out front. Okay. That's really like a -1, right? When we see negative f, that's really -1 times f. So, I see multiplication, -1 times that. I see x minus 2, x minus 3, order of operations. We multiply before we subtract. So my first transformation is going to be with that multiplication. Is that -1 times inside with the x, or is it multiplied to the y values? It's multiplied towards the f, which is the y value. So I need to multiply the y values by -1. So here's f of x. Just like in the last problem where I multiplied the y values by 2, now I'm multiplying the y values by -1. And what happens to the graph when we multiply the y values by -1? 1 times -1. 2 times -1. 3 times -1. 2 times -1. 2.5 times -1. 3 times -1. How would you describe this transformation? I goofed up something there, didn't I? There you go. That's supposed to be there. There we go. How would you describe that transformation? That is a reflection in the x-axis, right? We reflected the line in the x-axis. That's where the symmetry is. But we're not done. That was just step 1. Now I see this -2 and that -3 there. Well, that -2 is inside with the x's. If it's inside with the x's, we talked in our last lesson about it always working in reverse. So we don't subtract 2 from the x's, we actually add 2, which is going to take this graph and it's going to move it right 2. So I'm going to take these points after my reflection, after the first transformation, and now I'm going to add 2 to each x value to move it right 2. So this point, right 2. That point, right 2. Right 2. Right 2. Oh, I lost where I was at. Right 2, right 2, right 2, right 2, right 2, and right 2. All right, that looks good. The last thing. Whoops, why did that get so big? The last thing is this -3 up there. I notice that is outside of my function. Okay? So I'm applying that to the y values, not the x values. So if I take the y values and subtract 3, that's going to move this graph down 3. So now take those red points and move them down 3. Uh-oh, went off my graph here, didn't I? Poor planning. There it is. Okay. This is what I want your work to look like. Each transformation, step by step, graphed step by step. Don't try to do it all at once. Let's try another one. There's f of x. Oh, I guess I forgot to label these. Our final graph, g of x, is that one. Our final graph, g of x, is that one. I guess I labeled that one. All right, so f's in blue. Now, let's look at the transformations. I see this times 2 right here. I see a +1 there. Multiply first. Okay, so we're multiplying first. But it's inside with the x's, so it works in reverse. So we don't multiply the x's by 2, we multiply the x's by 1/2. So take each x value of the point and multiply it by 1/2. The x value of this point is 0. 0 times 1/2 is 0. X value of this point, okay, is 1. 1 times 1/2 is 1/2. 2 times 1/2. 3 times 1/2. 4 times 1/2. Notice I'm keeping the y's the same. 5 times 1/2. Oops, that one goes there. 5 times 1/2 is 2.5. I've only transformed the x values. Leave the y values the same. Okay. How would I describe this transformation? This is a horizontal compression by 1/2 because we multiplied the x's by 1/2. We squished it down. Now, our other transformation is that plus 1. So we did multiplication first. Now we go to the addition. Is that plus 1 inside or outside? It's outside. It's changing the y values, right? Because f gives us the y values. We're adding 1. That's going to move the graph up by 1 because now we add 1 to each y value. There's my function, g of x. Okay. I hope you're following along with this, building off what we talked about yesterday. All right, next one. Okay. What do I see here? I see I see a 1/2 times in front, but I see this negative inside, which is really -1 times. Now, in this case, they're both multiplication. So the order that we do these doesn't matter, okay, because they're both multiplication, right? If I multiply by 2 and then multiply by 3, I get the same thing if I multiply by 3 and then by 2. So here we can pick. I'll just choose to deal with the 1/2 out front. That 1/2 out front is changing y values. That is going to be a vertical stretch by 2. Multiply every y value that we have by 2. 2 times 2, 3 times 2, 2 times 2, 3 times 2. All right, that was step 1. Vertically stretched it by 2. Step 2 is that x's times by -1. But remember how x's work. Okay? Here we saw a times 2 there, so we multiplied by 1/2. We're always going to multiply by the reciprocal. But what's the reciprocal of -1? It's still just -1, isn't it? So this time we are multiplying the x's by -1 because the reciprocal of -1 is -1. What happens when I multiply x's by -1? What's 0 times -1? 0. What's 1 times -1? -1. 2 times -1. 3 times -1. 4 times -1. When we multiply x's by -1, we're reflecting in the y-axis. So I'm going to describe this step of my transformation as a reflection in the y-axis. We saw a reflection in the x-axis in this one because we multiplied by y's by -1. Multiplying by y's by -1 reflects in the x-axis. Multiplying x's by -1 reflects in the y-axis. This is my graph, g of x. All right, so now I'm going to step it up just a little bit. Okay. Here I provided you a graph of f of x. It was kind of a goofy little graph. This time I'm going to tell you an actual parent function here. And I'm going to tell you the equation of that parent function. And the parent function in this one is f of x equals x cubed. So my first step is to graph that parent function, right? That's the parent. This is why we made a parent curve book, so we know what these look like. X cubed has the point 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. It looks like that. Now, let's follow the transformations that I want to apply. I see a negative 3 times f. I see a plus 1 with the x, and a minus 2 with the y's. Multiplication before addition or subtraction. We got to do that times negative 3. Am I multiplying the x's or the y's? This is outside, it's the y's. So we need to multiply the y's by negative 3. And this is going to do two things, isn't it? Multiplying the y's by 3 is going to vertically stretch them. But the negative is going to reflect them. All right, let's just try some points here. 0 times negative 3 is negative 3, or 0 still. 1 times negative 3 is negative 3. 8 times negative 3 is negative 24. I'm not going to try to graph that. That's like way off the graph. Negative 1 times negative 3 is positive 3. You see how it's reflecting over the x-axis and stretching. It's doing two things. Reflect over the x-axis and stretch. So we get this as our new graph from that transformation. So I'm going to say it was a vertical stretch by 3 and reflect in the x-axis. All right, good. Now let's get to the addition and subtraction. Again, the order that we add or subtract isn't important. The x is plus 1, the y are minus 2. The x is plus 1 is going to move this left 1. The minus 2 on the outside are going to move the y's down 2. Remember, x's work in reverse, so we're subtracting 1 from the x, so that moves it left 1. Y's work as is, down 2. I'm okay if you do both translations in the same step. I know on this one, I went right 2 and graphed it, and then down 3 and graphed it. In this problem, okay, and in the future, I'm okay if you do both your left and rights and ups and downs at the same time. So, my last thing that I'm going to describe is that we are going left 1 and down 2. So take my green points, go left 1, down 2. Left 1, down 2. Left 1, down 2. And this is the graph of G. So I told you what f of x is, and we saw our transformations applied to it. Now, just to throw this in here as an extra step, if I gave you this instead, would you have still came up with the same graph? If I would have said g of x is negative 3 times x plus 1 cubed minus 2. That's the same g function as here, okay? Except now I actually, instead of using the f, the function, okay, notation, I actually just did it to the x cubed function. If I asked you to graph this, it's the same thing, right? Negative 3 on the outside, multiplication, vertically stretched by 3 and reflect. Plus 1 inside with the x, left 1, minus 2 on the outside, down 2. All right, new parent curve. Square root of x, points 0, 0, 1, 1, 4, 2, 9, 3. Those are some nice points on that graph. There's the parent curve. What are the transformations here? I see x is multiplied by negative 1/2. I see the plus 1. We'll do the multiplication first. It's inside with the x. So I don't really multiply by negative 1/2. I multiply by the reciprocal, which is negative 2. So what happens to the x values if I multiply them by negative 2? Don't touch the y's, just x's. 0 times negative 2 is 0. 1 times negative 2 is negative 2. Do you see what happened there? It reflected in the y-axis and was stretched out. 4 times negative 2 is negative 8. It's reflected and stretched. Okay, in the order that we stretch and reflect doesn't matter. It's going to give us the same spot, right? 9 times negative 2 is negative 18. Okay, that's off the graph. So I'm going to describe this step as horizontal stretch by 2 and reflect in the y-axis. That's the first transformation. The second transformation, this plus 1, that's outside, that's y's, that's up 1. That red graph is our final graph for g of x. By the way, what would g of x look like if we actually had that square root function there? Well, negative 1/2 x is going in for the add. So it's right, it's the square root of negative 1/2 x. That's on the inside of the function, that square root function, and that plus 1's outside. That's the same equation. All right, I'm going to call the video good there for now, this lesson. Hopefully that's enough for you to get started on graphing. If I give you the original parent curve, whether on the graph or the equation of it, and I give you the equation for the new function, follow the transformations. Multiply first. That's going to do stretches, compressions, and reflections. Add second. That's going to move up or down, left or right. Remember, anything outside is y values, it's vertical. Anything inside is x values and is horizontal. All right, thanks for tuning in. All right, we'll see you soon.